Hello friends, my name is Farrell, and today I'll be talking to you about parallel and perpendicular lines. Now this is part of our series on geometry, so if you haven't looked at the other videos, be sure to check them out first. And if you have, let's get started. So parallel lines, what do we mean when we say that two lines are parallel? Well, we mean that if you extend them into the distance infinitely, they're never going to intersect at any point, and they have to be on the same plane. So when a pair of lines meets these criteria, we can say that that pair of lines is parallel. So an example of that here in this diagram, you can see we have a rectangular prism here. The line AC would be parallel to the line EG, because they're going in the same direction. See, if you extend them infinitely, they're never going to touch each other. So we say that the line AC is parallel to the line GE, and you can see that they're on the same plane here. They're on the plane ACGE. That's the one on the left right here. And so the same concept applies to parallel planes. If you extend them infinitely, they're never going to intersect at any line. Remember, planes intersect at lines. So they're never going to intersect at any line, and they have to be in the same three-dimensional space. So an example of that here, again, in this diagram, you'd see the plane ACGE, and that would be parallel to the plane BDHF. And so if you extend them infinitely, they're never going to intersect at any point. And finally here we have skew lines. So now skew lines, they don't intersect, but they're not on the same plane. So to best understand this, you probably should look at an example. So an example of that here would be the line AC and the line DH. So you can just imagine them zooming past another. If you extend them infinitely, they just go right past each other, but they're not on the same plane. They're going in different directions, and they never intersect. So we can't call them parallel lines because they're not on the same plane. We call them skew lines. And we say that the line AC is skew to the line DH, or the line DH is skew to the line AC. Okay, good. So can you give me an example of parallel lines, parallel planes, and skew lines in this diagram right here? I'll give you a minute. Okay, so an example of parallel lines in this diagram would be the line AB and the line CD. Now this symbol right here in the middle, these two vertical lines, this is our symbol for parallelism. So the line AB, remember the line symbol is the one with two arrows on top. So the line AB is parallel, this is our parallel symbol, to the line CD. And that's our line symbol on top again. And yep, that's an example of parallel lines. There are plenty of others, but we won't mention them all for obvious reasons. And for parallel planes, you could say that the plane ABDC, that's the one on top here, ABDC is parallel to the plane EFHG. And again, we write it out using the parallel symbol here, the two vertical lines. Plane ABDC is parallel to the plane EFHG. Okay, good. And finally, for skew lines, we mentioned this earlier. No, wait, did we? No, we didn't. The line AB would be skew to the lines CG, DH, EG, and FH. So they're not going in the same direction, and they never intersect because they're on different planes. And because they're on different planes and they don't intersect, we call these skew lines. They're not parallel lines because they are not on the same plane. Okay, and so transversals. Transversals are important. These transversals are lines that cross two other lines. And so an example here in this diagram, line 1 and line 2 are being skewered by this transversal here. This line going through the pair of them, that's called the transversal. And over here you see a diagram with two parallel lines. When you see the arrows, two arrows on a pair of lines, that means that pair of lines is parallel. So the line L and line M are being crossed by this line Q. And in this case, we would call the line Q the transversal. So when we have transversals of parallel lines, pairs of congruent angles are going to be formed at the angles of intersection between the parallel lines and the transversals. So one set of these congruent angles are going to be at the corresponding angles. So you can see here that these angles are numbered. these are angles formed by a transversal of two parallel lines. And so the angles are numbered, and the corresponding angles are going to be the ones at like the same place in each of these little intersections here. So for example, angle 1, its corresponding angle would be angle 5 because they're both on the top left. And another example would be angle 2 and angle 6, and angle 4 and angle 7, and angle 3 and angle 8. So these would all be pairs of corresponding angles. And because of the corresponding angles postulate, we know that these corresponding angles are always going to be equal so long as these two lines are parallel and they're being crossed by a transversal. So we know that these two angles are these two angles are congruent. So angle 1 is congruent to angle 5, angle 2 is congruent to angle 6, angle 4 is congruent to angle 7, and angle 3 is congruent to angle 8. And so another pair of congruent angles would be alternate interior angles. So what are alternate interior angles? Well, they're the ones on the insides of the parallel lines. You can imagine that this here is the outside, on the outside of the two parallel lines, and this is on the inside. So the alternate interior angles, that means just on opposite sides of the transversal. So an example of that would be angle 3. Its alternate interior angle would be angle 5 because it's on the opposite side of the transversal and they're both on the insides of the parallel lines. So angle 3 would be congruent to angle 5 and angle 4 would be congruent to angle 6. And we know this because of the alternate interior angles theorem. And finally, our last set of congruent angles would be the alternate exterior angles. So alternate exterior angles is just like the alternate interior angles, except they're on the outside. So angle 2 and angle 7, they are alternate interior angles because this one's on the outside, they're both on the outside, and angle 2 is on the right, and angle 7 is on the left. And the other pair of alternate exterior angles would be angle 1 and angle 8. And so these two would be congruent. Alternate exterior angles are congruent. And we know this because of the alternate exterior angles theorem. And remember, these only work when it's parallel lines being crossed by a transversal. It won't work when it's not parallel. So finally, we have supplementary angles that are formed by transversals of parallel lines. So supplementary angles, remember, are angles that add up to 180 degrees. So on the same side interior angles, these angles are going to be supplementary. So for example, here, angle 4 and angle 5. These are same side interior angles. They're on the same side of the transversal. In this case, they're on the left side, and they're on the inside of the two parallel lines. So we know that angle 4 is supplementary to angle 5, and the other pair would be angle 3 and angle 6. And these are on the right side of the transversal, so they're also same side interior angles, so they're supplementary. And yeah, we know this because of the same side interior angles theorem. And so here's an exercise for you. Which angles are congruent to angle 2 and angle 3 respectively? I'll give you a minute. Okay, so angle 2, this is the one right here on the top right, it would be congruent to angle 4, obviously, because of the vertical angles. Because they're vertical angles, they're on opposite sides of an intersection of two lines. So these two would be congruent, and it would also be congruent to angle 6, because of the corresponding angles postulate. And yeah, they're on the same spot in these two intersections. So this is on the top right, and that one's in the top right. So they're corresponding angles, which means they're congruent. And finally, it would be congruent to angle 7 because of the alternate exterior angles. So these two are alternate exterior angles because they're on the outside and they're on opposite sides of the transversal. They're on alternating sides, which means that they're alternate exterior angles, which means that they're congruent. Okay, so for angle 3 would be congruent to angle 1, first of all, because of vertical angles again. And it would be congruent to angle 5 because of alternate interior angles. Yeah, they're on opposite sides of the transversal, and they're on the inside, which makes them alternate interior angles. And yeah, we know that they're congruent. So finally, it would be congruent to angle 8 because of the corresponding angles postulate. And they're in the same spot. They're in the bottom right. Both of them are in the bottom right, which means they're corresponding angles, which means they're congruent. And here's another one for you. So if the measure of angle 3 is 78 degrees, what are the measures of angle 6 and angle 7? I'll give you a minute again. So hopefully you've got that. Angle 6 would be 102 degrees because angle 6 and angle 3 are same side interior angles. And remember, same side interior angles are supplementary, which means they add up to 180 degrees. So 180 minus 78 is 102. So angle 6 is 102 degrees. And angle 7 would be 78 degrees because of the corresponding angles. These are both on the top right, and which means they're corresponding angles, which means we know that they're congruent. And remember that each of these postulates and theorems with the congruent angles and the supplementary angles, they all have converses, which means that if you can prove that the corresponding angles of two lines crossed by a transversal are congruent, then you know that the two lines are parallel. So basically we're doing the opposite here. We know that the lines are congruent, and we want to prove that we know that the angles are congruent, and we want to prove the two lines parallel. So the converse of the corresponding angles postulate, it basically means if you have a pair of corresponding angles that are congruent, then you can prove that the two lines being crossed by the transversal are parallel. And this all goes for all the other ones. So alternate interior angles, if you have alternate interior angles that are congruent, then you can prove that the two lines are parallel. And alternate exterior angles, you can prove that the two lines are parallel if you have those that are congruent. And the same side interior angles theorem, if you can prove that the two same side interior angles are supplementary, then you know that the two lines are parallel. And so transitive property of parallel lines. Parallel lines have a transitive property, which means that if line A is parallel to line B, and line B is parallel to line C, then line A is parallel to line C. So this is how you'd write it out in fancy ways. And yeah, so in this diagram here, let's say that we know that line I is parallel to line J, and we also know that line J is parallel to line K. And so we would then be able to know that line I is parallel to line K because of the transitive property of parallel lines. And so parallel lines have a few properties in relation to a perpendicular line. So first off, if two lines are perpendicular to the same line, then those two lines are parallel. So for example here, so if line A is perpendicular to line D and line B is also perpendicular to line D, then we know that line A is parallel to line B. So the perpendicular transversal theorem, that's a theorem. It says that if one of two parallel lines is perpendicular to another line, then they are both parallel to that other line. So, okay, let's say that line A and line B are parallel. We know this. And we know that line B is perpendicular to line D. We then know that line A would also be perpendicular to line D because of the perpendicular transversal theorem. Simple, right? And this only applies to lines that are in the same plane. So if you have two lines that are in different planes, then it doesn't count, obviously. And to summarize, lines that do not meet are parallel if on the same plane, and if skew if not. And planes that do not meet are also parallel, and these have to be in the same three-dimensional space. And a transversal is a line that crosses two other lines, and transversals of parallel lines cause congruence at corresponding angles, alternate interior angles, and alternate exterior angles. And there are postulates and theorems for each of those. And so transversals of parallel lines also cause supplementary angles at same side interior angles. That's a typo there, I guess you can ignore that. Yeah, they cause supplementary angles at the same side interior angles. So they add up to 180 degrees. And all special angle pair postulates and theorems have converses, which means that if you know that all these special angles are congruent or supplementary in the one case, then you can prove that the two lines are parallel. And parallel lines have a transitive property, which means that if line A is parallel to line B, then line B is parallel to line C, then line A is parallel to line C. And yeah, perpendicular lines intersect at a 90-degree angle. And if two lines are perpendicular to the same line, those two lines are parallel. And if two lines are perpendicular to another line, then they are both perpendicular. Let's say that again. If two parallel lines are perpendicular to the other line, one more. Sorry, you guys can edit this out, right? If two parallel lines are parallel to another line, then they are both perpendicular to that other line. What? That doesn't make any sense. And finally, if one of two parallel lines is perpendicular to another line, then they are both perpendicular to that other line. And so, oh no! And that's it. That's the end of today's video. If you made it this far, I'd like to thank you for attending today's lecture, and we hope to see you in future videos. And until then,